All right, everyone, get ready because we're going deep into time travel. And specifically, we're tackling the grandfather paradox. You know, that whole, what if you went back in time and accidentally stopped your own grandparents from meeting? Poof, you're gone, right? It's been used to say time travel just can't happen. But what if I told you there might be a way around it? What if the universe has some kind of safety net to prevent those contradictions? That's where things get really interesting. Recent research suggests that the laws of physics themselves could hold the key to this whole paradox thing. Think of it like a racetrack. You keep driving, you end up back where you started, even though you're moving forward the whole time. That's kind of what a closed time-like curve is like, a CTC. It's a path in space-time that loops back on itself, potentially allowing for time travel. Now, here's where the self-consistency principle comes in. Basically, it says that in a universe with these CTCs, things have to happen in a way that avoids paradoxes. So even if you tried to go back and stop your grandparents from meeting, something would have to stop you. Maybe you miss your flight. Maybe you suddenly hate setting people up. The point is, the universe would find a way to keep things consistent. But how does that actually work? Well, that's where things get a little mind-bending. It turns out that quantum mechanics, the weird world of tiny particles, might be super important here. You see, according to some theories, any quantum system traveling in a CTC would have to go back to its original state when it finishes the loop. That means no matter what you try to change in the past, you'd end up back where you started, with all your memories and everything. It's like the universe has a giant reset button, making sure the timeline stays intact. But wait, there's more. Remember entropy, that idea about disorder always increasing? Well, in a CTC, entropy would have to go back to its original state too, which means time zero would have to reverse, can you imagine? Instead of an egg cracking, picture a dead star suddenly reigniting, or a broken glass putting itself back together. That's the kind of crazy stuff entropy reversal in a CTC suggests. Now you might be thinking, wait, wouldn't that erase our memories too? And you'd be right to ask that, because that's another crazy part of these theories. Any memories or records made during time travel would have to vanish before you return to the present, preventing any contradictions in the timeline. It's a weird concept that makes you think about what it means to be you if you can time travel. If your memories can be erased, what does that mean for who you are? And it gets even wilder. Some theories say that at certain points in a CTC, entropy might be at its lowest, leading to something called a minimum entropy event. Imagine complex things like a brain or even a book suddenly appearing out of nowhere because of random fluctuations. It's like the universe is playing dice with physics, creating order from chaos in a way we don't understand. Pretty mind-blowing, right? But it also brings up another question. What about those classic time travel stories where you meet your younger self? In a universe with the strange rules of CTCs and the grandfather paradox. So we've talked about how time travel might not be a total free-for-all. There are these rules and principles, even quantum mechanics, trying to stop paradoxes. But what about those scenes in movies where someone goes back and meets their younger self? The ones that make you shout, "Don't do it, you'll mess everything up." Ooh. Well, if we're thinking about CTCs and self-consistency, those encounters might be different than we think. Imagine, instead of meeting your past self, you're meeting a quantum copy. This you wouldn't be you traveling back in time. It would be like a separate thing, a product of those random fluctuations we talked about. They might look like you, maybe even share some memories, but they'd be on their own path within the CTC. It's like the universe is saying you want to meet your younger self. Fine, but I'm making a copy to keep things straight. It's a way to protect the timeline from those paradoxes. And you know what? This actually makes you think about what it means to be you. If there can be many versions of you in a CTC, what does that mean for being one you throughout time? It's a bit confusing, but it shows how these ideas can make us rethink basic stuff about reality. But let's not get too lost in philosophy. We're talking time travel here, and there's a big question we haven't answered. If these CTCs exist, why haven't we seen any proof? Well, first of all, making a CTC would be incredibly difficult. We're talking about warping space-time so much that it loops back on itself. That's not something you can do in your garage. And even if we could make one, traveling through it safely would be another problem. Remember those quantum fluctuations? They can have some pretty weird effects. Think about it, you go back in time a few years, and suddenly you have an extra toe, or you can't stop eating pineapple pizza. The possibilities are exciting and scary at the same time. But wait, there's one more thing to think about. And this is where things start to get real worldy. Remember entropy reversing in a CTC? Some scientists think understanding that could change things, like in quantum computing and material science. Imagine being able to control entropy to make materials that are totally new, or finding new ways to store and use information, We're talking about changing entire industries with tech that sounds like sci-fi. But before we get too carried away, let's think about the bigger picture. Let's take a minute to think about what we've learned and what it all means. We started with a pretty simple question: can we travel through time? And as we've looked at the theories, the crazy implications, and even how it could change things in the real world, one thing's for sure. The answer is way more complicated than we thought. It turns out the universe isn't so easy to mess with. It's got these safeguards, rules about time and cause and effect, and while time travel is still a huge mystery, if we ever do figure it out, it won't be like in the movies. Instead, we might be dealing with a reality run by quantum mechanics, where self-consistency is king and the idea of who you are gets blurry. A reality where past, present, and future are all mixed up in ways we're only starting to understand. But even if we never get to jump in a time machine and change history, just thinking about these things has taught us a lot. It's made us rethink what we know about the universe, about time, about cause and effect. And it's made us appreciate all the crazy laws that control everything. And who knows, maybe what we've learned will lead to discoveries we can't even imagine right now. Maybe understanding time travel will unlock new things in quantum computing, materials, or even consciousness itself. Science is rarely straightforward. It's full of twists and turns and surprises. But that's what makes it so exciting, right? So, as we wrap up our deep dive into time travel, let's keep that sense of wonder, that thirst for knowledge, and be open to the unknown. Because it's in those places where we don't quite understand things that the biggest discoveries are waiting for us.